don't abstract for the sake of abstraction. This is important because there are people who do that and give abstraction a really bad word. Once I was giving a talk in France and I was told never to use that word because it meant bloat and complication. It doesn't, not if you do it right. Abstract for something concrete and efficient and maintain optimal performance as you go along during abstraction. In other words, you have to start with a real problem and then you have to generalize without losing the benefits. And my part of this is I want to represent concepts separately in code. I want to take things and combine them in useful and interesting ways. And I want to minimize overhead, sometimes by helping make language features that simply runs faster than what we had before. So minimize really goes low. So people ask me how much slower than C is C++, and that's the wrong question. It is when can C run as fast as C++, and it's not always. And generic programming has to be as simple as non-generic programming. That's my aim. Okay, that's Alex and an earlier version of me. And there's 3 design requirements that I outlined in DNA in '94. They were already a bit old, but basically this has to be general. You have to express more than any individual can imagine. The efficiency has to be uncompromised because otherwise people use lower level features instead of having the benefits of better concepts, better abstractions. And it has to be statically type safe. This has been my aim since the start with Simula. But of course that's hard if you have to manipulate hardware in interesting ways. So we're still trying to get there. But in the context of C++ generic programming, we are very, very close.